Hey everyone, welcome to my channel Code with GB. I am Gourav and I am a software developer. I create videos to help you become a better coder. So without further ado, let's dive right in. This video is fully focused on recursion. In this video, we will cover what is recursion and how it is used to solve problem statements. We will then look at some problem statements that need recursion and then we will code for them in Java. So let's get started. By the end of this video, you will be able to print numbers from 1 to 10 using recursion. You will also be able to print numbers in reverse order from n to 1. We will also print sum of numbers between n1 and n2 again using recursion. We will find factorial using recursion, and we will also print a string in reverse order by making use of recursion. So let's get started. Recursion is defined as a problem in terms of itself. For example, if we have a problem, can I break it down into a function of itself? For example, I have, say, f of x. Can I write it as something like y plus f of y, where the function is common? Let's see this with an example. Let's say my problem statement is, I will define my problem statement with f of n, or rather I will write f of 1 to n. This is my problem statement, and what does it define? It says print numbers between 1 to n. Now, can I define this problem in terms of itself? To do that, I can write this as f of 1 to n is equal to, I can print n, and then I can call f of 2 to n. So what I did essentially, instead of printing from 1 to n, I printed 1 myself, and then I called a function 2 to n to print numbers from 2 to n. Now let's say the value of my n was 5. So f of 1 to 5 is same as print 1 plus f of 2 to 5. Now after this will be same as 1 plus, now this can be further broken down as 2 plus f of 3 comma 5. This is because f of 2 comma 5 is essentially print 2 and then print numbers between 3 and 5. Now we can further break it down as f of 3 comma 5 is again 3 plus f of 4 comma 5. Now this f of 4 comma 5 is, I will print 4 plus f of 5 comma 5. 4 plus f of 5 comma 5. Now f of 5 comma 5 is essentially print numbers from 5 to 5, which we know its value is 5. So at the end I printed values. Now this is basically comma. This is not addition, I meant to show a relation. But yeah, so at the end I was able to print numbers 1, 2, 3, 4, 5 using recursion. So how do we code this? First of all, to identify if a problem can be solved using recursion, we need to define two steps. First is if the question can be defined in terms of itself. And the second criteria is there should be a base criteria. For example, in this case, our base criteria was if we have the starting and ending as same, we directly print that number without going further. So this will be the base condition in this case. Now let's solve this question. So we can define our recursive function. We could name it nums a comma b. So this means we have to print numbers between a to b. So our code will look something like this. So we need to print a, and then we will recursively call this nums function, nums a plus 1 comma b. Since we already printed a, the next time we will call nums for a plus 1 till b, and we will have a base condition that is used to stop this loop to prevent running it infinite number of times. So we can write if a is greater than or equal to b. So in ideal world we could have written if a double equals to b, we will like print a and then return. But just in case someone passes a parameter that is invalid, we need to have some kind of validation in our function to make our code more robust to invalid inputs. So in ideal world you would write if a greater than b, then throw some exception, but since we want to keep our code simple, let's go with this. Let's see how this plays out. Now imagine someone calls nums of 3 comma 5. How would that work? So first a will be equal to 3 and b is equal to 5. We will come here, we will check if a greater than equal to b, no. So we skip this block of if condition, we come to this line print a. So we will print a's value was 3, and then we will call nums of a plus 1. So this function now calls nums of a plus 1 is 3 plus 1, which is 4. So this will call nums of 4 comma 5. Now we come to this block of code. Is 4 greater than or equal to 5? No, right? So we skip this, we come here. So now our a was 4, so we print 4. So this is a and this is b. Then we come to this line, we call nums of a plus 1 comma b. So this will call nums of a plus 1 is 5 comma 5. So now our a is 5, this is a, this is b, and then we come here, we check is a greater than or equal to b. Yes, a is 5 and b is also 5. So we first print a, which is 5, then we return. So return will terminate the scope of this function and it will stop further execution. So this will return void to our previous function, that was nums 4 comma 5. So remember, the previous function did not actually go till the end. At this point the previous function called nums of a plus 1 comma b. So now this function will return empty to this, and this will return empty to this, and this is what our main function was. So at the end our output was 3 4 5, and we wanted exactly this, we wanted to print numbers between 3 to 5. So this is what recursion is about. We saw we had a base condition and we could define the problem in terms of itself. Let's now code for it. For this I will take user input is new scanner system.in. I want to take n as input, so integer n is input dot next end, and then I will print n. I want to first check that this snippet of code is running properly. Semicolon. Command. So I have to mention input here 12, and let's run now. Output is 12, so I was able to take input correctly. Next, I will create a recursive function as we had discussed here. So I will name it numsab, same as in the example. Private nums integer a to integer b, and I should call that function nums of 1 till n. Now we have to write our base condition, which is this base, which was written here. If a greater than or equal to b, I will print a and then return. Nothing after return means we are returning void, and the return type of this is also void. Should write here void. Now we have broken down this problem statement into first print a, then call nums of a plus 1 till b. So now let's run this code, and hopefully it will print numbers between 1 to 12. I also want to format it little, so I will print a space after every number. So that I print 1, then space, 2, then space, then 3, then space. It will just look better. I want to print numbers from 1 to maybe 9. Oh, I should define it as private static. Okay. So we have this 9 because I was printing to check input. So I will just comment it, and then we see we have numbers from 1 till n printed. If I change my input to maybe 15, and I will run this, and I got my numbers printed. I can give any number as large as maybe 15,000, and let's see what happens. Stack Overflow. So in online compilers we aren't allowed to print so much. Let's stick with 1500. If you run this locally on your computer, you won't see that error, just because I am running it online, so I was not allowed to use so much of processing power and memory. So you can see my numbers are printed till 1500. And yeah, that was it for printing numbers between 1 to n. So print numbers between 1 to n using recursion. This is done. So usually if you are told to print numbers between 1 to n, you will probably use a for loop where you will write for int I equals to 1 till n and then print the number. But in case the interviewer specifically asks to use recursion, then you can use this method. Now let's see how to print numbers between n to 1. To print numbers between n to 1, mostly you will like again write a for loop, start your I from 1 n and write a condition I greater than equals to 0 and then decrement I with each for loop. This is exactly what we are going to do with recursion. Instead of adding a number, we will reduce it. Yeah, so my problem statement now is print numbers between n to 1. This will be almost same as previous. Instead of incrementing a by 1, we will decrement it by 1. So for example, initially my nums was, I had a nums function a comma b, and so let's take an example. So if our nums is 5 to 1, we need to print 5, 4, 3, 2 and 1. So now our nums function will look something like this. At our base condition, if a is equal to b, for example, the base condition of this will look like nums of 1 comma 1. While solving a recursion problem, you have to figure out the base condition even before writing the code. You should know what your base condition will look like. So I know my base condition will look something like this, nums of 5 comma 1. So my base condition will be if a double equals to b, I want to print a and then return. Now if a is not equal to b, I will simply print a and then call the same function again by decrementing a. So a minus 1 till b. For reasons of parameter validation, I will write it as if a is less than or equal to b. I want to break that function and return the result, because in this case, if you see, print numbers between a to b in decreasing order, a should always be greater than b. So I had here 5 to 1. I first printed 5, then I called nums of 4 comma 1, which gave me this. So let's look at this diagram. So I had nums of 5 comma 1, my a was 5 and b was 1. Then I came, so my a was 5, I checked here, is 5 less than 1, I got no. So then I will print I will print a, which was 5. Then I will call nums of 5 minus 1. So I will call 5 minus 1 is 4. So 4 comma 1. Now I again check this. Is a less than equal to b? No. Next I will come here. I want to print a. My a is now 4. So I will print 4. Then I will call nums of a minus 1 comma b. So a minus 1 is 4 minus 1, which is 3. Now this will become 3. I will again come here. I will see a is 3. I print 3. Then go here. It will again call nums of 2 comma 1. A becomes 2. We print 2. This will then call nums of 1. And we come here. We see that now 1 is not less than 1, or in fact 1 is equal to 1. So we print 1 and then we return from this. So further execution won't happen, and this function then returns here. The control in this nums of 2 was at this point, so there is nothing to execute after this. So this will again return back, and this process will continue, and this will be our final output, 5 4 3 2 1. So this is how we print numbers in reverse order. Let's look at the code for it. So we already had our code present. we just need to make one small change. We now need to print numbers between in reverse order. So I can just reverse these. Let's say okay, so I can write a nums n to 1 and my integer a and b are same. This base condition will change. So my base condition here was if a less than equal to b. So if a less than or equal to b, I want to print a and return else. Now this as recursive function call will also change. It was a minus 1. I will write a minus 1 and now I will run this. Let's take a smaller example, maybe 15, and run. Yeah, so I got my result 15, 14, 13, 12, 11, 10, 9, 8, 3, 8, 7, 6, 5, 4, 3, 2, 1. So this is how you print in reverse order. I can put an extremely bigger number as well and it will still work, maybe 150, and run. Now you can see the output, it goes on till 1 and you might be seeing till 4, but the screen is not being captured, it goes on till 1. Now going back to the list of questions, we were able to print numbers between n to 1. So I will just take this off our checklist. Then we need to print sum of numbers between n1 to n2. Let's look at this, how we will do by recursion. My problem statement is, let's say I'm given a function n1 and n2. I want to find the sum of numbers between n1 and n2, and we know that n1 is always less than n2. This is part of the problem statement. You won't find a set of inputs where n1 is greater than n2. So with this constraints, let's start solving. Now to solve a recursive problem, as I said, we need two things. One is base condition, the other is define the problem in terms of itself. Actually, this is the first part. First you need to decide, you need to write the function in terms of itself and then figure out the base condition. Now to convert this as a problem in terms of itself, I can write add of n1 and n2 is same as I take n1 and add the remaining result, that is n1 plus 1 till n2. Now this is same as this because, for example, n1 is 3 and n2 is 7. What this means is I need to find sum of all numbers between 3 and 7, like add numbers 3 plus 4 plus 5 plus 6 plus 7. Now I am saying this is same as 3 plus add 4 till 7. Now let's look at this objectively. So 3 to 7 is basically 3 plus 4 plus 5 plus 6 plus 7, and this is 3 plus add 4 to 7 is 4 plus 5 plus 6 plus 7. Now the result of this will give 4 plus 3 is 7, 14, 24, 25. And if you add all of these, you will get 3 plus 7 plus 4 is 11, 16, 22, which is equal to 25. So both of these are same. So this is the correct assumption. Like this formula is the current assumption of defining the problem in terms of itself. For the base condition, we can look at it as something like this. Now 3 plus addition of 4 till 7 is same as 3 plus 4 plus the function as 5 till 7. Now this will go on as 3 plus 4 plus 5 plus addition of 6 till 7, and at the end you will get something like 3 plus 4 plus 5 plus 6 plus addition of 7 comma 7. Now you can define this as the base condition, because after this we don't want to perform any operation. So you can define the base condition as a state where both n1 and n2 are same. So this was n1 and the second parameter was n2. So base is if n1 double equals to n2, we need to stop the execution after adding the sum. Now let's look at how we will programmatically write it. I will call my function sum of n1 till n2, and my code will be something like this. My base condition as discussed is if n1 double equals to n2, I will return n1 plus, I will just return n1, because the sum of numbers from n1 till n1 will be n1. Now if, let's take an example. Let's say my n1 is 3 and n2 is 5, or let's say it is 7. So after this step, I want to at the end return n1 plus, let's look at our criteria. Our criteria was 3 plus addition of n plus 1 till n2, which was 3 plus add of 4 till 7. So at the end I want to return n1 plus sum of n1 plus 1 till n2. Let's see how this plays out with the code. So at the first pass, n1 was 3, n2 is 7. I reach here, I see if n1 is double equal to n2. No, n1 is clearly less than n2. I come here. So I want to return n1 plus sum of n1 plus 1. Now sum of n1 n2, this is returning 3 plus sum of n1 plus 1 is 4 till 7. So n1 is now 4. Let's see, 4, is it equal to 7? No, it's less. So this will return 4 plus sum of 5 till 7. So this will be returning 5 plus, it will be 4 plus sum of 5 till 7. Now n1 is 5. n1 is 5. So is 5 equal to 7? No, we move next. So sum of 5 comma 7 will return 5, which is n1, plus sum of 6 comma 7. Now our n1 is 6. So we check, is 6 less than 7? No. So then it will return 6 plus sum of 7 comma 7. Now this will return 6 plus sum of 7 comma 7. Now our n1 is 7, n2 is 7. We go to this function. We check if n1 double equals to n2. Yes, our n1 is equal to n2. So sum of 7 comma 7 will return n1, which was 7. So sum of 7 comma 7 gave us 7. I will write here 7. So what is 6 plus 7? It is 13. So now this returned 13. Now what is 5 plus 13? 5 plus 13 is 18. So this will return 18. What is 18 plus 4? 22. So this will return 22 here. This is 22. 22 plus 3 is 25. So we get 25. So this way, sum of 3, 7 gave us 25. Now let's code for it in Java. Now I need to take two inputs, n1 and n2. We'll modify the existing code. Let me do this. I will just delete this. And I need to take two inputs, n1 and n2. Comment this. I can see that both of the inputs are showing correctly. So now let's move to actually code the problem statement. So I have created a function sum which takes n1 and n2 as input. I will rename this as well, sum, and it takes, let's say, integer n1 and integer n2. Now let's look at what the base condition should be. It should be if n1 double equals to n2. So let's write that down. If n1 is double equal to n2, I want to return n1. I can return either of n1 and n2 since both of them are same. Next, I want to return n1 plus sum of n1 plus 1 and n2. So let me write that down. So return n1 plus sum of n1 comma n2. It will be n1 plus 1, because if I have n1 as 3, then I need to do 3 plus sum of numbers from 4 till 7. Now with these inputs, let's run this. I also want to do one thing. I want to print the result. So I can assign the final result in an integer, and then I want to print it. Yeah, let's run this. Okay, so the problem is I did not change the return type. Since my code is now returning integer, I need to change it to integer. My bad, it was a slip of mind. Yeah, as you can see, we got the output as 25, and this is exactly what we had calculated. Now you can put any numbers here, any number as large as, like, let's say 150. I hope it doesn't throw error. Alright, it threw memory overflow error because I'm not allowed to do so many operations. Let's say 15 and run. Yeah, you can see the output is 117. You can cross verify this as well by adding the numbers or maybe using a calculator. So this checks our third question. Print sum of numbers between n1 to n2. Next is find factorial. Factorial is defined as the product of the numbers from 1. For example, factorial of 5 is equal to 1 into 2 into 3 into 4 multiplied by 5. Factorial of 0 is always 1, and factorial of 1 is also 1. Factorial of 2 is 1 multiplied by 2, and factorial of 3 is 1 multiplied by 2 multiplied by 3. So now that we know the problem statement, any guesses what the base condition will look like? So if you look at it, it is same as adding numbers from n1 till n2. The only change in operation is instead of plus, we have a multiplication. So instead of this, we can now replace it by multiplication, and in place of n1, we always have 1. since it's a multiplication of numbers from 1 till n. So for example, in this case, factorial of n2 is same as if we change n1 to 1 and replace this plus with multiplication. There's one extra change in the base condition. So factorial of 0 is always 1. So this also we need to make sure of. So regarding change in the code, our sum will now change to factorial of, let's say, factorial of n. So factorial of n is, the base condition for this is if n double equal to 1 or n double equal to 0, we need to return 1. Similarly, if we didn't hit the base condition, we want to return n into factorial of n minus 1, because factorial of f is same as factorial of 4 multiplied by 5, because remember this is same as 1 into 2 into 3 multiplied by 4 multiplied by 5, and factorial of 4 is 1 into 2 into 3 into 4, and then at the end we have 5. So now let's quickly look at the code. I will make minor changes to the code and it will work. We need to take only one value as input. Now we have factorial. I will change this as well. This comes from the base condition that says if n is 1 or 0, and at the end we need to return n multiplied by fact of n minus 1. Let's print the result for factorial of 4 and check. Okay, here's the problem and run. So output is 24. So we can calculate 4 multiplied by 3 is 12, multiplied by 2 gives us 24. So this answer is correct. This checks our second last problem, find factorial. For the final problem statement, that is print a string in reverse order, I will write down the code for it, and I expect you to figure out what is happening in the code. And you can also run the code in your compiler and execute it and play with it to know more about recursion. But if you have any doubts in explanation, like why I am writing a certain part of code, let me know in the comments down below and I will reply. And that's our output. So this is our base condition here and this is our logic. So that's it for today's video. See you in the next one. Thank you for watching the video till the end. If you liked the video, share it with your friends. Don't forget to subscribe for more such videos. Till then, happy coding. Bye bye.